Hi everyone, Dr. Schmidt here making your section 5.1 video. We're going to start on this page here. Now this first problem in guided practice activity number 1 is done for you, but I just wanted to explain some of the details. So when they say cost is proportional to the minutes that you speak, remember from chapter 3, that means this, where K is called a constant of proportionality. Now when they tell you the rate is 5 cents per minute, that means K is 5 cents per minute. And FYI, this symbol right here, C with a line through it, is cents. That's not a symbol you see a lot nowadays. Next, we're going to assume there's a fixed cost of $20 each month. That's why they're adding 20 on right here. So the problem here is they've given us cents and dollars. We need our units to be consistent. So we have to convert the 5 cents into dollars. So if we have 5 cents, the conversion factor that you have to multiply by, like we've done in previous chapters, we'll have to divide by cents. Cents will need to be in the denominator so that they cancel. And then we have to remember, well, how many cents are in a dollar? There's 100 cents, 100 pennies in $1. But of course, we don't put the dollar sign after the number 1. We put the dollar sign before the number 1. So that's your conversion factor, and that gives you $0.05. So that is K converted to dollars. So that gives us our cost equation is 0.05 times minutes. Or, once you include the fixed costs, the equation would become 0.05 times minutes plus 20. And again, you need to make sure to convert the K into dollars because they gave it to us in cents. Sometimes they'll give you mixed units that you'll have to convert, sometimes they won't. Now once you have these two equations, this equation and this equation, you just plug in all these different minutes for M. Plug them in, and that's how they have these numbers here. Once you get those numbers, you plot the points. So I'll show you just a couple really quickly. The 125 is this one, because you go out to 100 on the minutes axis, and you go up to 25 on the cost axis. Another point that we have here is 100,5. That's this one. You go out to 100 on the minutes axis and up to 5 on the cost axis. So what they've done here is they've plotted both of these on the same graph. This one is C equals 0.05 M. This one is C equals 0.05 M plus 20. So a couple of things to notice here. This 20, this is called a y-intercept. You're going to learn more about this in 5.2. We just want to start building your intuition now. Notice that this number, 0.05, that's the same for both equations. They have the same rate. Rate is something that is also known as, aka also known as, slope. You're going to learn more about that in 5.2. For now, just to build your intuition of what slope is, it tells you how steep the lines are. So notice they have the same slope. So the lines have the same steepness. They're equally steep. So that's just a quick overview of their first example that they've worked out. And now I want to work out an example in detail for you and then leave you to practice some more. So here we have the weight of water. They say the weight of water is proportional to the volume. So that means W equals KV. And they said the rate is 8 pounds per gallon. So K equals 8 pounds per gallon. So if you put those two things together, you get this equation, 8V. You put that together there and there. Now, if you're using a bucket to carry water that weighs 10 pounds, that's extra weight. It's not the weight of the water, it's the weight of the bucket. It's extra. So that's why they've added on 10 here. So this equation would be 8v plus 10. So now they've given us a bunch of volumes in gallons, and we have to calculate the weights without the bucket, and after that, we'll calculate the weights plus the bucket. So the way we do this is we take 8 times 0, because we're using the volume 0 here, and that of course will give us 0. And then we'll take 8 times 0.5, that'll give us 4. Then we'll take 8 times 1.5, that'll give us 12, and so on and so forth. Oops, I did the wrong row. That goes here, because this 1.5 is this 1.5. 8 times 1.0 goes here, that'll give us 8. And you get the last two values in the same way. So over in this last column, now we have to take 8 times v plus 10. Well, we already did 8 times v right here, so all we have to do is add 10 to get to the next column. So 0 plus 10 is 10. Of course, 4 plus 10 is 14. 8 plus 10, of course, is 18, and so on and so forth. 22, 26, 30. Now that we have all these numbers, we're going to plot the points. So to do that, we use these values here for the vertical axis, and we need to label that. So that's going to be weight in pounds, and the horizontal axis will be volume in gallons. You always have to specify your units. And that is from here. The weight is here. The weight is also, we're going to have two graphs, just like in our first example. The weight is also going to have 10 pounds added to it. But let's start with our blue weights without the 10 pounds. So that's this first dot, because our first value is 0. And then our next weight is 4, when the volume is 0.5. So we need to start here at volume and go up to 4. That gives us our next point. And then our next one is 8, when volume is 1. We have 8 pounds when volume is 1. So we go from 1 up to 8 right here, and so on and so forth. From 1.5, we go to 12. From 2, we go to 16. From 2.5, we go to 20. So those are these points. Next, we need to do our green ones. So we have to start with 10 when volume is 0. So when volume is 0, our first weight is 10. We've already got that one right here. Next is 14 when volume is 0.5. So when volume is 0.5, we have 14, which will be right in between 12 and 16. Then we have 18 when volume is 1. 18 is going to be right here in between 16 and 20, and so on and so forth. For 1.5, we've got 22. For 2, we've got 26. For 2.5, we've got 30. And then you connect the dots. You could have connected the blue dots before you started connecting the green ones, or just draw all the dots and connect them. But if you're not color coding, just make sure you connect the right dots. Got to keep the blue dots connected and the green dots connected, but you don't want to mix them. So just like in our first example, notice these lines have the same slope, and they just have different y-intercepts. This y-intercept, which I'm going to abbreviate y-int, is 10. This y-intercept is 0. Now I'm going to leave it to you to try number 3. That would be good practice. You can skip number 4. And then we'll move on to objective 2. So if we go on to guided practice activity number 1 in objective 2, number 1 is already done for us. Number 2 is what we were just doing. We just did this in objective 1. Number 2, we just did that. That was W equals 8V. And then if we're adding on the weight of the bucket, we would have W equals 8V plus 10. So I'm going to leave you to try number 3 and number 4. And that's the end of 5.1.